Hello viewers, how are you all? Hope you are doing well. So today I have come with another interesting new video of our 3-dimensional geometry lecture series, lecture 27. So today we are going to discuss the coplanarity of two given lines. So before we start today's lecture, I want to inform you that we are going to use the concepts what we have discussed in the lecture 7 today. So see, today we are at the lecture number 27, but we are going to use the concept discussed in lecture 7. That is the reason why in each video I am telling you, please go through my previous lectures. Mathematics is a sequential or stepwise process. So you have to go stepwise. If you go through previous lectures, then it will be very easy to understand what I am discussing today or in the future. Okay, so without wasting any time, as usual, we will understand the whole outline of the theory by using a beautiful mathematical model. Okay, so today I am going to use my pen tab as our mathematical model. Okay, babu একবার এসো তো দেখি বলে বাবালে আচ্ছা এই জায়গাটা কাট করতে হবে বেশ so today I am going to use my beautiful pen tab from XP Pen as our model, mathematical model. I have considered this as the plane. Now see these beautiful models made of CP wood. So now I consider these two as a line. So here I keep this like that. So we are going to derive the condition for which these two lines are coplanar, that is lie in the same plane. Now see, as I have told you, we are going to use the concept of lecture number 7. In lecture number 7 we have learned the equation of a line, that is their lines, equation of a line passing through a particular point and parallel to a given vector. Now here two lines are there, so they pass through, let us consider they pass through a particular point, say capital A with position vector a1 vector, and this line passing through a particular point, say capital B with position vector a2 vector. Now also we consider these lines are parallel to a given vector, say this line 1 is parallel to b1 vector and this line 2 is parallel to b2 vector. We will demonstrate this like this. Say this line is parallel to this one b1 vector, maybe here or here, parallel to this line l1 is parallel to b1 vector, and this line 2 is parallel to say b2 vector here, or maybe here or here, b2 vector. Now regardless of the position of b1 vector and b2 vector, if we take the cross product of b1 vector and b2 vector, what will be the direction of the resultant of b1 cross b2? It must be perpendicular to this plane, right? But the point capital A with position vector a1 vector and the point B with position vector b vector lies in this plane. So if we join this AB line segment, we get the line segment AB. Then this line segment AB must lie on this plane, right? Hope you have understood up to this. So if this line segment AB lies on this pen tab, that is the plane, then this line segment AB must be perpendicular to the resultant direction of the resultant b1 cross b2 vector. So again we are using the concept of dot product of vectors, that is AB vector dot b1 cross b2 equal to 0. Then we are done. That is, from this we are going to derive our desired condition to be the two lines as coplanar. So thank you for helping me. Thank you, Mr. Model. So now we will start the proof in detail. Okay. So first we will draw the diagrams. See here, in white color I have drawn the plane. Now we will draw two lines. Line 1 in red, line 2 in blue. Now proof. This one line 1, this one line 2. Let the given lines be L1 R vector equal to A1 vector plus lambda times B1 vector, equation 1, and L2 R vector equal to A2 vector plus mu times B2 vector, equation 2. So here line 1 for say is passing through say this point capital A with position vector A1 vector, and line 2 is passing through the point B with position vector A2 vector. So line 1 is passing through capital A with position vector A1 vector and parallel to the vector B1 vector. Similarly, line 2 is passing through the point capital B with position vector A2 vector and parallel to B2 vector. So here I will draw this one say B1 vector and this one say B2 vector. So line 2 is parallel to B2 vector, line 1 is parallel to B1 vector. Now if we take the cross product, then this will be the direction, this yellow line should be the direction of B1 vector cross B2 vector, which must be perpendicular to the given plane. Now we are going to join the point AB by yellow dots. Now we will go to the next page. Now as points AB lie on plane, therefore AB vector, that is the joint of points A and B, A vector must lie on the same plane. So therefore AB vector is perpendicular to B1 vector cross B2 vector. So therefore by the property of dot product, AB vector dot B1 vector cross B2 vector equal to 0. But AB vector is what? AB vector is position vector of B vector point B, that is A2 vector, minus position vector of the point A, that is A1 vector, implies green. A2 vector minus A1 vector dot B1 vector cross B2 vector equal to 0. So we are done. We have derived the vector equation of the condition of coplanarity of two given lines. So this is the equation say 3 is the condition of coplanarity of two given lines. Now we are going to see the Cartesian form. Now here you can observe that one vector dot two vectors are in the cross product. So this is nothing but scalar table product. So we can write this as this: A2 box product, A2 A1 B1 vector B2 equal to 0. So this is another form. Now we will see the Cartesian form. Cartesian form of the condition of coplanarity of two lines. So therefore, let A1 vector, let us consider that the point A, capital A, has coordinates x1, y1, z1. Then A1 vector equal to x1 I cap, y1 j cap plus z1 k cap. And A2 vector equal to, similarly we can write x2 I cap, y2 j cap plus z2 k cap. Now let the vector b1 vector and b2 vector have direction ratios a1 b1 c1, small a1 b1 c1 and a2 b2 c2 respectively. Let direction ratios of b1 vector and b2 vector are a1 b1 c1 and a2 b2 c2. Therefore b1 vector equal to a1 I cap, b1 j cap, c1 k cap. Here also we are using a particular note. 3 points we have discussed in my previous lectures. So again my humble request to you that if you directly come to this video, please go through my all previous lectures, then you can understand each and every word I am using here. And b2 vector equal to a2 I cap, b2 j cap plus c2 k cap. So now we just simply put the values. Here it is a box product, so we know that it can be written as in the form of determinant. So just simply put the values in the determinant. So a2 minus a1 vector means x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap, and b1 b2 vector we take the components from here. So Cartesian form is, therefore Cartesian form is x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. If this determinant value will be 0, then we can say that two lines in the space must lie in a same plane, that is these two lines are coplanar. So now we are going to see a beautiful application of the theory what we have learned right now. So go to the next page. See, so that the lines these and these are coplanar. So here these two lines are in the which form? Vector form or Cartesian form? Cartesian form. So from here first we write solution. From the after reading the question, we will just write down the data. Okay, so a1 vector equal to components, we just write the components. Okay, minus 3 1 5. a2 vector equal to minus 1 2 5. We are just writing the components. In examination hall don't write this. In examination hall you just write simply a1 vector equal to minus 3 I cap plus j cap plus 5 k cap, a2 vector equal to minus I cap plus 2 j cap plus 5 k cap. Okay, So and b1 vector direction ratios of b1 vector equal to -3, 1, 5 and direction ratios of b2 vector equal to -1, 2, 5. So now just we check after putting values in the determinant whether these two lines are coplanar or not. If the determinant value comes 0, then it will be coplanar. Otherwise, we can say these two lines are non-coplanar. So next page. So x2 minus x1 means here we just deriving this page graph green color. Okay. X2 minus x1 means here this one is x2 y2 z2. This one is x1 y1 z1. So x2 minus x1 -1 plus 3, so 2. y2 minus y1 means 2 minus 1 1. z2 minus z1 means 5 minus 5 0. Okay. So next page. x2 minus x1 y2 minus y1 z2 minus z1 a1 b1 c1 a2 b2 c2 equal to take blue. Okay. Previous page. So these things we have already derived 2 1 0. 2 1 0. Now what is a1 b1 c1? a1 b1 c1 is here. a1 b1 c1 here a2 b2 c2. So -3 1 5 -3 1 5 previous page -1 2 5 -1 2 5. So here 2 into 5 minus 10 minus 1 into minus 15 plus 5. So equal to 5 minus 5, so minus 10 plus 5 minus 10 plus 10. So here we got the value 0. So therefore the two lines undo the lines are coplanar. So done, proved. So now I will give you one home assignment. Go to the next page. Oh no, no home assignment. Actually, I am giving home assignment in every videos, but you are not solving and not commenting on the comment section. So that's why this section is empty. So first solve all the previously given home assignment and put the answers in the comment section below. Then from the very next video I will definitely give home assignments. So thank you for watching. Hope you have enjoyed today's video.